Welcome to my lecture series in R. This is Shakil Ahmed. In today's tutorial, we will learn how to apply statistical tests like equality of means using survey weighted data. So again, we consider the NES data set from 2005 to 2018, which consists of different demographic information of US individuals and on health and nutrition status, but we are just using demographic variables. So I just imported the data and renamed data as the patient's characteristics like sex, age, income, ethnicity, marital status, education. So we just need to pre-process the data before applying the test, and we again construct a survey design from object using primary sampling unit and the survey weight and the stratification variable, which we discussed in our earlier videos. So today we just discussed statistical test like just t-test. So t-test is mostly used because it is alternate of basically the standard normal or z-test in case of unknown variance, and we are basically estimating variance of the variable. And in case of larger sample sizes, we the t-test, the result of t-test just approaches to the result of normal standard normal test z-test. So it, the two tests are equivalent. So mostly we perform test on using statistical student t-test. So we just start to perform a t-test on a variable for equality of mean for the single sample. Basically, we are just checking that whether the mean age is equal to 0 or not. This is here the comparison is given for 0 only. So although it is not logical to compare the age with 0, it should be compared with mean age. So you can just make a variable age minus mean, and then that variable the mean of that variable should be equal to 0. You can equate to 0. So for now I am just testing the hypothesis that a mean age is equal to 0 or not, although this is not a proper statistical hypothesis. Just for sake of understanding the code, I am using this hypothesis. So this is survey t-test, SVY t-test, and then the variable which you are comparing and your hypothesized value, and the survey design object, that is I have already constructed. And then if there is any NA, that would be removed. So you can just see uh, what result we get. The t value is 167, that is too large, as we are comparing mean to the 0, that is definitely significant different from 0. And the alternative hypothesis is the true mean is not equal to 0. So definitely the null hypothesis will is rejected, and we have this. And it also gives the confidence intervals like confidence interval for mean, that is 36.79 and 37.67, and the true mean is x bar is basically 37.2. So this is just a test for single sample. Now we come to the two sample problem, where we have two independent samples, like we are comparing uh, mean age by sex. For example, we said that There is no significant difference in age of males and females, the average age of male and female. So you can just test this hypothesis using survey t-test again. Now you are using age, and the sex is basically the factor which you are using. That is your uh, grouping variable. Based on sex, we are dividing the data into two groups, male and female. So you can just perform this test. Observation, there is a warning that observations with zero weight not used for calculating dispersion. So while estimating the standard deviation, the values without weights, zero weights are excluded. This is just a warning. But in our data, we have no such data. We have already weights on all observations. So you can see the result. You can just see the result like this, just running this part. So here is the t value is 10 and degree of freedom is 108 and the p value is 2.2. So you can see that there is a significant uh, difference between the mean of two groups, and the mean difference is 1.914, and you can just see the confidence interval as already given. You can again run with this command, and the other way to apply an independent sample t-test is to use survey GLM. You can see basically at this time we are taking age as a response variable and running a linear regression of response on the factor that is sex. So the basically the beta is the difference between the two groups. Uh, that is the effect of x on y. So you can just see uh, now you can see if you compare the results for confidence interval, this is confidence interval for the difference. Here the confidence interval is for the coefficients, and it is not giving any confidence interval. You can just see the estimate, that is 1.9, and it means the mean age is higher for uh, female, I think, as we are given one for male and two for females. So then higher mean is for females, higher ages. And this is standard error, and this is the t value, and this is the p value. So this is significant from zero. So this is another way to perform a t-test to check whether there is a difference between the response between the two groups. So, but in t-test we need to assume the equality of variance. If the variances in the two groups are not equal, then you need to perform a Welch test. For Welch test, I think there must be some survey uh, t-test command, but the survey t-test we are using just assuming that the variances are equal as per my knowledge. So, but on the safe side, you can just check using survey GLM command. That is, you are taking age as response variable and sex as independent variable or predictor. And the last one is the paired sample t-test, that is used to compare before paired observation. Basically, we have data on two variables are the same variable before and after certain intervention. or before certain experiment or after certain experiment. So this is just a data on physical activity that is performed for some time, and this is the physical activity performed some other time. So we are just checking whether there is a difference between these two physical activities or not. If the difference is zero or not, you can just test in similar fashion, and you will get now the t value, that is 9.8 again, and the mean difference is 5.8. So there is a significant difference between two groups. That means the alternative hypothesis true mean is not equal to zero. Here basically we are discussing the mean of difference that is equating to zero. In independent sample t-test, we are first finding the means. We have means of the two populations or the two groups, and we are comparing the two means. But here we have uh, only one sample, but observation on two different occasions. You can say these are paired sample, that is the same sample taken before and after, so the population is same, and we are just uh, first uh, taking difference of the two responses, and then the mean of that difference is equating to zero, if whether the mean of the dead difference is equal to zero or not. Although you can perform the similar test using the one sample t test again, using the difference as the response variable and then equating to zero. So that's all about some basic tests. In next video, we will discuss probably about the regression models for survey-weighted data. So thank you for watching, and don't forget to subscribe the channel. Thank you.